Hello everyone. For lab exercise number 3, we're going to be using stellarium again to look at 4 special points in Earth's orbit. These are known as the annular motions of the sun, and these points are what we define our seasons by. So you're going to need to navigate to stellarium. Make sure you are somewhere near Bowling Green. Right? You can use the auto location feature if you are near Bowling Green, or you can manually type in the location that you want, which you will need for the second part. Okay. You will need to turn on the azimuthal grid system. So you'll recall this is a coordinate system that consists of altitude, 2 angular measurements called altitude and azimuth, right? So if you note these horizontal lines going around the sky, this gives the angle of altitude, right? Which represents how high something in the sky rises in the sky, right? So the point straight over your head is what is referred to as zenith, right? So looking out, as if you were laying in a field looking out toward the sky. Zenith would be here at the point directly overhead. Now the vertical lines give the azimuthal angle, right? So the azimuthal angle runs from 0 to 359 degrees. So starting at north, which is defined as an azimuth of 0, east is defined as an azimuth of 90, right? And south, 180. West, 270. This is a little hard to see because the function of this website, but if you can kind of peek behind through this semi-transparent bar at the top here, it shows what azimuth line this is, right? And then we come all the way back around to north. So also notice that the altitude lines, they start at 0 around your horizon. Right. So over here on the right side of the screen are the lines for altitude, right? And then they go upward to the point directly overhead, which is at 90 degrees, right? So altitude ranges from 0 to 90 degrees. And so we're going to look at the path of the sun at these 4 different special times in the year. So we're going to start off in Bowling Green, and if you look at Lab 3, starting with the fall equinox, you're going to look at the sunrise, the time that noon occurs, sunset, and then you're going to calculate from sunrise and sunset the length of the daytime hours. Now, I will give you a little hint here. Equinox is derived from a Latin term which literally means equal night, right? So during the equinoxes, we have about equal amount of days of sunlight as we do, not days of sunlight, hours of sunlight as we do hours of dark, right? And then you should have observed over your lifetime that during our winter solstice, or what we think of as winter here in the northern hemisphere, right, we have the shortest amount of daylight. On the contrary, in the winter, during the summer solstice, right? So around June 20th of every year, we have the longest day, right? So the longest amount of daylight of any time of the year. And this pattern occurs every year. The time of equinox and the date will sometimes vary a day or two from year to year because we have a leap year. But it typically occurs between the 19th to the 20th, 21st of March for the spring equinox, and around 21st, 22nd of September for the fall equinox, right? So I've estimated the dates for this exercise. And so now let's talk about what noon is, how we define noon. Going back to our out as system, in an earlier chapter, you learned about the celestial meridian, right? So this is an imaginary line that runs from north to south, right? And so it's going to run right along this line here. So noon, let me go back to earlier today. So here's north, south here. These are reversed, east and west, because we're looking from the perspective of the ground out, right? Instead of top down. So as we watch the sun progress across the sky, notice that the sun never goes directly overhead, which is indicated by the center point here, right? So the time that we define as noon, we're given there's a few different names for it, right? So some people will call it solar noon time, or local noon, or high noon, right? And that's because noon is defined as the time that the sun crosses the prime meridian. So this line that runs from across the sky from north to south, which also corresponds to the time when the sun is at its highest altitude, its highest point in the sky during the day. All right. So when you are calculating noon, right, you're going to find the point where the sun is highest in the sky, right? That will coincide with when the sun crosses this north-south azimuth line, right? Which the sun is traveling across the southern part of the sky, right? So you're going to want to look for this 180-degree azimuth line. And then when you zoom in, and you can adjust the minute time here and figure out exactly when this occurs, right? You're going to put the timestamp when the sun is crossing this line, right? And then for the altitude, you're going to look here to the right side of the screen, and you're going to estimate the altitude based on the readings here, right? So this is a little over 47 degrees. You can round it to the nearest degree for this exercise. And then for sunrise and sunset, you are asked for a direction. So let's go ahead and look at we're close to the March equinox here. So let's skip down here to March 19. The equinox is actually on the 20th this year. You can do it on either the 19th or the 20th. There's the variation within one day isn't enough to throw you off a lot. So let's go back to sunrise. Right. So notice that at our spring equinox, the sun is rising exactly here in the east, right? So remember we said east is at an azimuthal angle of 90 degrees. So the sun is rising right here in the east, okay? So when you're asked for this direction on sunrise, if it's due east or due west, right, meaning that it's rising right around this 90-degree azimuth line for for sunrise, or the 270-degree azimuth line for sunset, right, then you can put those directions as east and west. However, let's back up here to March 20th morning. All right, so this is sunrise on March 20th, or around the time of sunrise, okay? So what if we skip ahead a few months and look at the summer solstice? Or let's just say look at the next month, right? So let's look at sunrise on April 20th, right? Notice that the sun is no longer rising due east, right? The sun is now shifted northeastward, right, to the north. So now the sun is rising northeast. Now the sunrise will shift in this direction. So looking at May, the sun is rising even farther toward the north, right? Even farther away from the east, right? And it does this until it reaches its maximum deviation from east, which occurs at the time of the summer solstice, right? Now, for the second part of this exercise, you are going to look at, you're going to basically do the same thing, only now we're going to go to a site on the equator. So I think I chose Quito, Ecuador, which lies right along the equator. Right, so you can choose any address in Quito, Ecuador. Right. And what you want to make sure right here on the latitude and longitude is that you are pretty near zero latitude, right? Meaning you're right along the equator of the Earth. What you want to do, actually, before you do this, is turn off your auto location, right? or it will just bounce you back to Bowling Green. Quit. No, not quit. I want keto. All right, and then use this location. So then you're going to repeat the same process, but you're going to see some differences, right? Because now we're not in the northern hemisphere. We are right along the equator of the Earth. So we are looking at the sun's progression through the sky, right, which is caused by our orbit around the sun, from a different perspective on the Earth. Okay. All right. I think that's about all I want to cover. I'm going to try to keep this video short. So in the case that anybody already turned in the assignment and you feel like you've done something wrong and you want to resubmit it, that's perfectly fine. I will just grade the latest submission when I go to grade them. Yeah. All right. That's it, everyone. Good luck, and I will see you next time.